Alright, honors, here we go. This is a fun section, solving exponential equations. Alright, this is a unit out of the Big Ideas book, 6.5, but all the problems that you need are right here in these slides. So you could be looking at the Hello Smart slides, or if you look at the Big Ideas book, that's on our website, Unit 6, or Chapter 6. This is Section 6.5, but go to our slides, everything's on there that you need. Alright, so all these slides are in the Hello Smart slides. Alright, and I'm going to do a few examples, and the rest of the examples I have all the solutions up there as well. So you can do a few examples on your own. So I'm going to do a few with you guys. I'm going to take this slow, okay? We'll do a few examples, from 3 to 12, and then I'll give you guys some time to practice. Alright, so here's a equation, 4 raised to the 5x power equals 4 to the 10th power. Alright, so 4 to the 5x power, this is definitely exponential, right? So y, if you just reimagine this as y equals 4 to the 5x power, you'll get something, right? And then you have another equation here that you have y equals 4 to the 10th power. Well, there's no exponent there, so y equals 4 to the 10th power is just 4 to the 10th power. It's a pretty large number, whatever that happens to be. So really, this is just, if you just put 4 to the 10th power, it is 1, 0, 4, 8, 5, 7, 6, so 1, 2, 3, 1, 2, 3, 1, 2, 3, so we got about a million, 48,000 change. So I'm asking, when does this exponential y equals 4 raised to the 5th x power, which is exponential growth, right? And this equation, which is y equals 1 million and change, is just a horizontal line, and they're going to intersect. And what x value do they intersect, right? So that's what I'm asking you to do here, right? So I'm giving you two equations. I'm asking when they intersect. When does this exponential equation intersect this horizontal line? Yes. We can grab our graph and calculator and we can figure that out. Or we can take like another simple route, okay? So what I want you guys to realize is the base here is 4 and the base here on the right and left side is 4. So when you have the same bases, well, then you could just eliminate the bases and just set the exponents equal to each other. And if you do this, you got x is equal to 2. So again, you can do this graphically on your graph and calculator, or just take the algebraic route. But the bases have to be the same. Alright. In Algebra 2, they'll show you techniques where the bases are not the same, and you cannot make them the same, and then they'll show you different routes and different techniques to solve for that. But we'll leave that for Algebra 2, okay? So here's another example, number 4, okay? So again, you have the same bases, 7 and 7, and the exponent here is x minus 4, and the exponent here is 8, so when does x minus 4 equals 8? Well, when x is equal to 12. Done. Piece of cake. You got this. Alright, so now I got 3 to the 9x power, 7 to the 3 to the 7x plus 8 power. I'd probably pause my screen here and make sure I can do it on my own first, and then watch the rest of it. So I'm just going to got the same bases here. No problem. Subtract 7x from both sides. You get 2x equals 8. X equals to 4. Piece of cake, no problem. Alright, and then 2 and 2, we got the same bases again. So when does 4x equal x plus 9? It's the same when 3x equals 9, or when x is equal to 3. Right, and let's see what else we got. So the remaining problems that we're going to do, so we did 3, 4, 5, 6, and I left the rest of them for you. Okay, so from 7 on, 7 to 12, okay, so these are in the Hello Smart slides. You can then look at those slides, and then you have your answers here to check your answers. Alright, so here's a couple more, a little more challenging, okay, but fun, okay. So now I'm going to really test your skills of exponents. So 1 over 5 to the x power equals 125. So they don't have the same base. So do I graph this? Sure, why not? Or we could make sense of this and say, wait, there's a 1/5 there, there's a 125. There is some kind of relationship. Well, I know 5 to the first power, second power, third power is 125. So there's a relationship between the 5 and 125, okay. 1/5, 1 over 5 is the same thing as writing 5 to the negative first. So, wait a second. So if I think about that, then I have a 5 to the third, base of 5, and a base of 5 here. So I'm going to rewrite 1/5 as 5 to the negative first to the x power. I'm going to rewrite 125 to 5 to the third. And I'm going to apply my laws of power to a power. So this is 5 to the negative x equals 5 to the third. And now I have the same base 5 and 5, and now I can get rid of my base and say that negative x equals 3. Therefore, x equals negative 3. So when x is equal to negative 3, then these answers are, then the left side is equal to the right side. And you can check that. So what's 1/5 to the negative third power? Well, 1/5 to the negative third power is, right, this is technically all over 1, or one thing about that way, you could do the reciprocal, which becomes 5 over 1 to the third power, which then equals 125. Nice one, right? Alright, take a look at another one. 1 over 27 and 9. So 27 and 9 have a common number there, common base. What is it? And hopefully you see that it is going to be 3. So 27 is 3 to the negative third power. 9 is 3 to the second power. Right, that's equal to 1 over 27. This one's equal to 9. So I'm going to rewrite this one as 3 to the, oops, joking. Not negative 3, but 3 to the negative third power, all raised to the 4 minus x, and equals 3 squared to the 2x minus 1. And then I'm going to apply my laws of exponents. So this is going to be negative 3 times 4 minus x. Alright, so that's why I put the parentheses there. I haven't really done that in the past. But I just want you to remind you that this is negative 3 times that quantity of 4 minus x. So you have to distribute here. Okay, so be careful on that one. And then this is 3 squared. You'll multiply those. 2 times 2x minus 1. Again, having to distribute there, which is why I put those parentheses here. So we got negative 12 plus 3x equals 4x minus 2. I'm going to bring my x's over. I got negative x is equal to, add 12 to both sides is equal to 10, and x is equal to negative 10. And again, we could always verify by plugging it, going back and plugging in, seeing if they are the same. But you should see that they are pretty good there, right? So here I skipped a few steps, so just if I lost you there, right, I added 12 to both sides, and I subtracted 4x from both sides. And that's how I got my negative 1x equal to 10, and then divide by negative 1. Alright, and you get x is equal to negative 10. And again, you can plug into both sides, and you'll see that both sides are, in fact, equal. Alright, so there's two examples. And then I have a bunch of answer keys for 13 to 18. Alright, so there's 13 to 18. A few examples there. Whatever's left, all yours. And the answers are there, so you can check your work. And then 25 to 36 was using a graphing calculator. You won't be able to solve any of these algebraically. None of the bases are the same on any of these. So this is optional if you want to do this. It's just, again, just going back in and putting both equations in, playing with the window a little bit. Can you see both intersections, and then can you find a point of intersection? All right, and I did post a video online on this. It's either in Exponential or Exponents. I think the video is in Exponential, just how to find the intersection again. All right, if you can't find it, please just email me and I'll get you that video out. But this is just more using the graphing calculator practice. This is another set of problems here, okay? Similar to the ones we did, except with one extra step here, and I'll do one of them for you. So 37, and again, I think I have all the answers there for you as well. So we'll just do one, and they're actually very similar to the last ones. You have 30 times 5 to the x plus 3 power equals 150. All right, so now you have an a value in here, not just a b value raised to some exponent, okay? So The only difference you're going to do here is just divide by 30 first. Isolate that, and you have 5 to the x plus 3 power also happens to equal 5 to the first power, right? Just remember, there's a first power there. If there's no, if you don't see a number there, it's just first power, right? So every number has an imaginary 1 times it and raised to a first power as well, okay? So this is 5 to the x plus 3 power equals 5 to the first power. And I'm just going to set the two exponents equal to each other, and I get x equals -2. Alright, then you'll see, again, you can plug that in to make sure. -2 plus 3 is 1, 5 to the first is 1, 5 times 30 is 150, check. Alright, and just a couple more examples there. So we did 37 through 40. They work pretty much the same way. Have fun, enjoy them, and then again, here's your answers to those. Another group of problems, 43 to 46. 3 to the 3x plus 6 equals 27 to the x plus 2. Let's see, let's take a look at this one. Alright, so 3 and 27 should look like nice numbers for you, equals. And I'm going to rewrite 27 as 3 to the third power and to the x plus 2 power. Alright, so just keep in mind, I'm going to put the parentheses there. Now my bases are the same, so I have 3x plus 6 as the exponent here, equals, and then I'm going to take that whole piece here and do 3 times x plus 2, right? So I'm just dragging that whole exponent down, right? Power to a power is multiplication, and then I just have this, and I have 3x plus 6 is equal to 3x plus 6. Oh, look at that. I have the same thing on both sides, so this is what? This is an example of all real numbers or infinite solutions, right? So when will these two equations intersect? All the time. Okay, and then there's a couple more examples out there for you with the answers as well. And then 53 to 58, these are fun. I'm going to do 1 or 2 of them. I think I'll do 2 of them with you, and then we'll let you guys do them yourselves. So now we're extending the rules, and we have square roots here. So let's rewrite this. So we have 8 to the x minus 2. And then hopefully you could be thinking about how else can you write the square root of 8. We came out of this a lesson or 2 ago. The square root of 8 can also be written as an exponent as 8 to the 1/2 power. So that's what I'm looking for here, right? I'm looking for you to recognize that the square root is the 1/2 power. And now cancel out your bases, and you have x minus 2 is equal to 1/2. So x is equal to 2/1/2 or 5/2. And one more, so you can see what we have here. And number 56. Alright, cool. So we have 12 to the 2x minus 1 equals the fourth root of 12 raised to the x power. Cool, I'll take that. So there's not much I could do with 12, so this is just going to be the same, but this 12 is buried underneath the fourth root, so I got 12, and the fourth root is going to be my numerator, and raised to the x power, so x over 4. Right, so that can all be written as, right, the fourth root of 12 to the x power, right? The root is the, whatever your root is, that's going to be your denominator piece of this, and then that will be your numerator piece of this. So then I just have 2x minus 1 equals x over 4, and however you want to solve this, it doesn't matter. Okay, remember this is 1x over 4. Multiply through by a common denominator, just break it up, like whatever is easier for you. I'll just multiply everything by a common denominator, just keep my numbers easy. So I got 8x minus 4 equals x, 7x equals 4, x equals 4/7. Alright, if you just take your time with the algebra, you'll be able to do it there. Alright, so I just brought that over and that over at the same time. I'm going to divide it by 7, and you got x equals 4/7. Alright, and you can plug that in and see, verify that it works, and it's all good. Alright, and then, so that's 53 to 58. Some are more challenging, so I'll leave those for you to try. The answer keys are also on here as well. Alright, so you have everything you need for this last section here. Good section, have fun with it, and I'll see you guys soon. Hope all is well.